This is the 1982 free response question from the AP Chemistry exam, dealing mainly with stoichiometry. If you have not done this question on your own yet, I highly recommend that you stop this video and do it yourself. See how many points you could have gotten on your own without any help from me, and then come back and we'll talk about how many points you could have had. Remember that 4 out of the 8 possible points, or half of the possible points, is enough to get you a 3, and anything above that puts you well on your way to that 4 or 5. So let's dive right in. Just from looking at this, I can tell this is going to be from the first part of the test, where you have 13 minutes or so for this question. I can tell because I have numbers, and it's asking me to do some sort of calculations. So let's dive into it. Water is added to uranium fluoride, and it produces some solid that has uranium, oxygen, and fluorine in it, and a gas. It says the gas is 95% fluorine and the rest hydrogen. From this, we're supposed to be able to determine the empirical formula of the gas. Well, if the gas is 95% fluorine, then the other 5% must be the hydrogen, because that's the only things present in the gas. So anytime we have percentages and we're asked to find empirical formulas, we're going to assume we have a 100-gram sample. So we change these percentages to grams, because 95% of 100 is 95. Once we have grams, we know that an empirical formula is a mole-to-mole ratio of one element to another. So we need to convert these to moles. Molar mass of hydrogen is 1, which is probably the easiest conversion. So hydrogen is 5 moles of hydrogen present. Fluorine, we look up on the periodic table, is 19 grams per mole. So 95 divided by 19, plug it in the calculator, it comes out to be 5 moles of fluorine. Now we divide by the smallest number. Now since they are all both the same, we're just going to simply divide by the smallest, which is 5 in both cases. So therefore the empirical formula, H1F1, or just HF, the ones are redundant. So we'll put a little square around that, or a circle, so our grader knows that that's what we want them to see. Give me my points. Next, we're asked to find what fraction of fluorine of the original compound. So what's the original compound they're talking about? The original compound, where the only place fluorine could have came from, was that UF6. Is in the solid, we want to know about the solid, and in the gas. So we're going to have 2 answers for this one. And what fraction? So this is going to be some part per whole. So we want to know the fluorine that's in the gas out of the original amount of fluorine present. Let's just call this fluorine naught, original fluorine. And then we want to know the fluorine in the solid. And the part, again, is going to, or the whole, is going to be the original amount of fluorine. So we need to figure out how much fluorine we originally had. So let me make some room here. I don't need this. All right. We need to know the percent fluorine in uranium 6 fluoride. So to do that, we take how much fluorine there is in that compound. So this is 6 times 19 divided by 238, because that's uranium, and fluorine is 6 times 19 again. And that's going to give us our percent composition of fluorine in uranium 6 fluoride. Multiply or divide this out, we get 0.324. All right, so how much did we originally have to work with? Well, we know that the original sample was 4.267 grams of uranium 6 fluoride, and 32% of it is fluorine. So how much fluorine did we have originally? So we're going to take the original sample's mass 4.267 grams of Urac-6. And we're just going to figure out how much fluorine we originally had. Multiply these together, and fluorine, the total amount of fluorine, was 1.38 grams of fluorine in the original sample. All right, of that 1.38, how much made it into the gas? So, different color. Fluorine in the gas would have been, if we had 0.97 grams of gas, which is HF, we know that that's 95% fluorine. The original amount of fluorine we had was 1.38 grams of fluorine. So these two multiplied together gives us 0.92. 0.92 divided by 1.38 is 0.667. If we change that into a percentage, we'd be better off. But it didn't ask for a percentage, so we'll just leave it at 0.667 fluorine in gas. I want to spell out gas. And then to figure out the fluorine in the solid, it would be 1 minus that, right? Because together they have to equal a whole. So this is 0.333 fluorine in solid. There we go. And already you can tell it's important to put those boxes around these because things can get a little messy. Next, we're asked to write the formula of the solid product. Oop, there goes my screen. Well, the reaction again was that water, there's a random blue box of death, and uranium hexafluoride reacted to form hydrogen fluoride and some uranium fluoride oxygen compound. And we know that the original sample's mass was 4.267 grams. And we ended up with 0.97 grams of the gas. And we want to know what these subscripts are here for this. We just figured out that the fluorine had a mass of 1.38 initially. And of that 1.38, 0.333%, or 33% of it, made it into this solid. Right? Because the other 66% went into the gas. So we've got the fluorine. So let's get the next bit. What about the uranium? Where did the uranium have to come from? It had to come from this 4.267. So we can figure out how much uranium we had if we remember that the fluorine came from it. So this 1.38 is how much fluorine was present there. So if we subtract these two, it'll tell us how much uranium we originally had. So the original sample had 2.887 grams of uranium. This is going to come out to be 0.46 grams of fluorine. I guess it's redundant. I don't have it on one line. All right. And the last thing is what about the oxygen? How do we figure out the mass of the oxygen? Well, if we know the mass of the fluorine and we know the mass of the uranium, and that's all that could be into that solid, the original sample's mass, the product's mass was 3, get rid of this, and the sum of that. This had a mass of 3.73 grams. We've already accounted for how much fluorine was in it. We've accounted for the uranium, 887. So if we just subtract all that out, we find that the oxygen had a mass of 0.383 grams. So now we have grams of each thing, and we're asked to find an empirical formula, which is not that hard. So again, we divide by their molar mass. Fluorine is 19, uranium is 238, oxygen is 16. We'll get how many moles of each of these are present. So we get 0.12 moles of uranium, 0.24 moles of fluorine, and 0.24 moles of oxygen. Divide by the smallest, 0.12 is the smallest. This one's easy. Uranium is 1, fluorine 2, oxygen 2. So our final empirical formula is U1O2F2. And it really doesn't matter what order you put them in, so you could also say UFO, because that's funner to say. 1, 2, 2. Either one would be fine. Typically, you want your least electronegative compound in the front, your most electronegative compound at the end. So UOF would probably be a better formula to write for this, but we can have some fun. Chemistry doesn't have to be that awful all the time. So there's that. Lastly, it says write a balanced equation for the reaction between UF6 and H2O. Assume that the empirical formula of the gas is the true formula. So we have UF6 plus H2O. And we've already said we know that this makes a gas. We called that gas HF, so we might as well keep going with it. And we said that it makes UFO 1, 2, 2. So you got to keep going with it. If you didn't know how to do parts C and B, you can still get some easy points here by simply making believe. So you could have said, let the empirical formula equal UOF. And as long as you followed that through down here, you could still obtain these points. A good thing we're not doing that. We know what we're doing. But if you're ever desperate, good way to cheat. So balancing, I have 1 uranium, I have 1 uranium. I have 2 hydrogens, I have 6 fluorines. I'm going to need 6 fluorines on this side. 2 are already spoken for, so I need 4 more. So let's put a 4 there. That gives me 6 fluorines, 6 fluorines. I have 4 hydrogens. I'm going to need 4 hydrogens. That gives me 4 and 4. And then 2 oxygens, and I am balanced. So let's start assigning some points for this. Starting at the top. This question, A, was worth 2 points. 1 point awarded for determining moles to mole ratio and then translating that into an empirical formula. Now, if you did not come up with the correct mole to mole ratio, as long as you followed it through in your empirical formula, you can still get this 2nd point. If you did not divide by the smallest and you said H5, F5, That's only worth 1 of the 5 points. Number B is worth 2 points as well. 1 point is awarded for determining the total amount of fluorine present, and 1 point for both fractions. So 60 or 0.66666 repeating and 0.33333 repeating. If you left them as 2/3 and 1/3, that is also correct. They will give you points for equivalent answers. So 2/3 and 1/3 would be the equivalent answer to what we have here. Letter C was worth 4 points. Ooh, there's a lot there. So 4 points for letter C. You received 1 point for determining the mass of uranium present. You received 1 point for determining the mass of oxygen, 1 point for all 3 mole values, converting them all to moles, and 1 point for an empirical formula that matched. Now, if you didn't know how to do this, if you said let the mass of uranium equal, and as long as the number was less than the mass of uranium hexafluoride or uranium 6 fluoride, if your mole ratio was followed through with that, you could receive points for that. And the same with oxygen. Let the mass of oxygen equal, and as long as it was a number less than 3.73, you could have received those points as long as your mole ratios matched up and you found an empirical formula to meet that. Lastly, a balanced chemical equation was worth 1 point. So for a total of 1, 2, 3, 4, 5, 6, 7, 8. This question apparently was worth 9 points. So if you got 5 points or better, congratulations, you are well on your way to a 3, 4, or 5. If you received 4 points, that's iffy, you're close. You would have to do very well on a multiple choice portion. And if you receive less than 4, well, just keep working on it. These take some time and some getting used to.